All right, wonderful students. So quiz 305 was about comparing models. This quiz had a lot of different skills. So for those of you in the live lesson, we stayed and we went over it in the second half an hour. And in the beginning, we just kind of started talking about some of the ideas and the bigger concepts because there's a lot of definitions and different pieces to put together. So we're going to dive in and I'll do like a mini lesson for each one and then try to apply it. Okay, so this is a great apply it type quiz once you have that idea. So if you have the exact variation, check if it makes sense. If you don't, that's all right. You should be able to follow the same steps and apply it in your situation, which is a great thing about math class. Which description compares the domains of function A and function B correctly? Okay. So now we have two separate representations of a function. We have the equation, right? The math version, and we have a graph. Function A is f of x is equal to negative 3x plus 2. Function B is this graph, g of x. So we need to ask ourselves, do we know what the domain is? And if you don't, remember, you're welcome to Google. You're welcome to search. You're welcome to, I should stop giving them free advertisement. You're welcome to search on the internet for that information. Your notes, your book, domain. What is a domain of a function? And it's the x values. It's all of the possible x values that our function can take on. So if you just recognize this equation, you're like, wait a minute, that's an equation of a line. Great. Think about a line, the x values, all of them. We're going to go graph it, but that's what I need you to start thinking about. Like, what do I know? Like, I know some things. And it'll build that confidence in learning new material, learning vocabulary, learning technical vocabulary. We had negative 3x plus 3, I forgot. Plus 2. Look, it's a line. And then again, domain talks about the possible x values that the function can take on. So graphically, you just look as we zoom out. These are big x values. It's just going to keep on going to negative x and keep on going to positive x. It'll be negative y, but there is no domain or range restrictions, so we would say all real numbers. That's it. The domain of this function is all real numbers. It can be anything. That's not the same with this one. Remember, graphically, we're going to go look and we're going to be like, what x values will it take? Some key details. That's a solid dot. Where is that solid dot? Followed up, that's an arrow. That arrow lets us know it's going to keep going. That matters because you could have like stop. You could have a hard stop on both ends. You could have an open circle, right? We've seen that with piecewise functions and whatnot. Where is that? That's 0, 0. What is the x value? 0. Can it be equal to 0? Yes, because it's a solid dot. Will x ever be less than 0 in the negatives? No, there's no graph over there. But can it be positive? Yep. And that arrow says it's going to keep on going. So here the domain, the possible x values, is all x values that are greater than or equal to 0. So you're going to have to be careful and look at your details for your variation. Okay. Whoop. Set of real numbers. Function B, set of real numbers greater than or equal to 0. It's a key distinction. Okay, the other ones are wrong, but read them, see if they make sense, what they might mean, and then you might have different variations. If you don't know what log x is, graph it. Log x. Oh, hold on. Log parentheses. Oh, whoops, no, never mind. We don't need that. We need to zoom in. Log x. Oh, we have an issue. That's a whole x can't equal 0. You can check it. Undefined. Okay, so check your graphs. Use the tools and technology. Okay, so we have a problem with log. There's your graph. Read the tick marks carefully. Read the tick marks carefully. Check the class recording if you want more help. We went over both of these. We went over all 3 variations in the different class recordings. So go back, look for 305, and then you should be able to have the answers if you need more support. Okay. Question 2, which comparison is correct for the values f of x and g of x where x is equal to negative 2? First question, we compared graphically and by a function, and then I went and used a graph to talk about domains. Now we're talking about input and output values. So let's see what they want. Aha! We have another equation, and now we have a table of values. Well, they give you a calculator. Let's use it. I like Desmos, of course. I think it's better to practice with that. Zoom out. Okay, so here we have our calculator, and we need to think of what does it mean when x equals -2? Well, that means we're going to substitute -2 in to x, right? So we need to do f of -2, and we need to compare it to g of -2. We need to compare them. Comparison usually says greater than, less than, or equal to. We're going to compare them. So we're going to, which one's larger, which one's smaller? Are they the same? That's typically what we mean. But it could be something else. Your answer's choices will be a clue. How do we do this from a table? So let's do the table of values before we do substitution, right? You can be working on that if you already know that you take wherever you see x and you substitute in -2, and then you evaluate it. For a table, we look on our table of values. Well, they're saying when x equals -2. Well, this is the x column. There's -2. This is our g of x. So guess what? That is actually our g of -2. It equals -1. G of -2 equals -1. So that's exactly what you do on a chart. You find your x value, you slide over to your function value. You have your x value, your input, you have your y value, your g of x, your output. Okay, that's it. That's what the table is telling you. That's what the column headers mean. As you go down the column and you slide across the row, that's the input, and then it gives you the output. Okay, let's do this now algebraically. F of -2, we're going to plug it into the calculator. So in here, we're going to do 3 minus parentheses, -2, close parenthesis, squared. Because I substituted it in where I saw x equals -1. Pen, it equals -1. Oh, okay. So boom, it equals -1. They both equal -1, so they're equivalent. That's how you're going to do it. So you're going to find what is your function value based on the table. So again, you're going to look for whatever value they're asking you on your table. Like, okay, where is it? Okay, it's -2. That's my x. That's my g of -2, -1. Then algebraically, you're going to substitute it in. You can use a calculator. F of -2 is equal to 3 minus -2 squared. That's equal to 3 minus 4, because -2 squared is -2 times -2, which becomes +4. Then we do the 3 minus 4, and that's equal to -1. And they're the same. Your variation might be different, but that's the same skills, and they give you a calculator. Oops. Question 3. Variation 3. It's usually what I do. All right, 2 trains, planes, and cruise ships. There's an old movie, planes, trains, automobiles, trains, planes, automobiles. I can't remember which one's first. We're going to go ahead and do trains. 2 trains left the station, traveling in opposite directions. The distance train A traveled is modeled by the function d of t is equal to 81t, where d represents the distance in miles and t represents the time in hours. Train B traveled a total of 324 miles in 4 hours. How does the distance train A traveled in 1 hour compare to the distance train B traveled in 1 hour? All right. We have a common concept here. We have miles per hour. It's usually what we speak in here in the States. This is a thing that I hope you all learn. It's distance equals rate times time. I call it the DIRT formula. My physics teacher in college said it's the DIRT formula. DIRT kind of looks like it spells dirt. DIRT. The DIRT formula applies in all situations. If you want to know the distance, you just need to know how fast you're going and how long you were going that fast. So you need to know your rate and your time, multiply them together, and you'll find your distance. That's a basic concept. It's pretty cool. It's pretty powerful. Keep it in mind. You can also rearrange this to find other information. If you know how far you've traveled and you know how long it took you to get there, you know how fast you're going. Because rate is just your distance divided by time. Think about that. Miles per hours. Okay. And then very similarly, if you want to know time, and you know how fast you're going and you know how far you went, you do distance divided by rate. So that these are a triangle of facts. They're related to each other. They're what we call related equations, but they're just useful to kind of have in your mind because this type of calculation is something that you'll actually do. I know we have it in our phone. We plug it in our phone and we're like, oh, it's going to 3 hours to get there. But you want to be able to do this estimation for yourself. Okay. All right. Now that we have that out of the way, that's a little prior knowledge and maybe not, maybe some review or maybe some new information like, oh, I've never seen that before. B, train B, we want to know its miles per hour. And then train A, based on our equation, they tell us our miles per hour. Because remember, distance equals rate times time. So what is the rate? 81. How do I know it's miles per hour? Because it says miles and hours. So it has to be miles per hour. Otherwise, it really wouldn't make sense. You want to keep your units. Units do matter when you're dealing with equations. So, all right, now train B. Hopefully you're thinking about it and you're already ready. You're like, oh, I get this now. But I want to know the rate. Well, we have a formula for that. Or you can just think about it. Like, how fast were you going if you went, I'm sorry, 324 miles in 4 hours? How would you figure out how fast you were going or how far you went in 1 mile? Well, you need the unit rate or you need to divide. And look, watch this. 324, write out the word miles, divided by 4 hours. And look at that. You have the perfect relationship that becomes 32 divided by 4 is 8. 4 divided by 4 is 1. Feel free to use a calculator. Boom, it's right there. 81 miles per hour. All right, so now they're both going the same speed. So after an hour, what will their distances be comparatively speaking? Hopefully you said the same. And if not, just think about that for a minute. If you're going 81 miles per hour and you travel 1 hour, how far did you go? 81 miles. And if that doesn't make sense, just take a second to think about it. It's that one question, I think it was on America's Funniest Home Videos, people were asking each other, if you're going 60 miles per hour, how far do you go in 60 minutes? Or yeah, something like that, or an hour, whatever they say to the person. And they're like, what? And their brain, like, they don't get it. But you do get it. We just need to take some time to really think about it. And that's the part that we're not doing. Train A traveled 1 hour is equal. The distance train A traveled in 1 hour is equal to the distance train B traveled in 1 hour. I'm sorry. All right. Boom, boom. Question 4. Whatever variation you have, same steps are going to apply. Identify the rate from the equation. Find the rate given the distance and time. Compare. Compare after 1 hour. Both of them will give you a unit rate or the mile per 1 hour rate in your question 3. A description, which description compares the vertical asymptotes of function A and function B correctly? Okay, so here's another vocabulary word. Way back in Unit 2, we talked about asymptotes and how to find them graphically and from the equation. Asymptotes of a rational function are caused when we have division by 0. So we check our denominator for values of x that will make it 0. X plus 4, what value of x would make it 0? If that doesn't make sense, I'm going to show you in a second. I just need to scroll down. Okay. Graphically, we just look at it. Look at where is the asymptote, the dotted line. It's right there. X equals 2 for function B, for g of x. I don't know how they're going to label it in my question, but that's important. Okay. For function A, my asymptote will occur where my denominator becomes 0. The denominator is the x plus 4. So I ask myself, what values of x will cause it to equal 4? 0. -4. That's where my next asymptote is. Students also notice, this is like our vertical shifts. This is a rational function. If you have 1 over x minus c, it's going to be the opposite. So the asymptote will be at x equals c. And if you have plus d, that's our vertical shift, your horizontal, this is a vertical asymptote, sorry, see up and down, vertical. Your horizontal asymptote will be at directly d. If it's the c, x minus c, it'll be the opposite, right? That's +4, so the asymptote's at -4. If it's plus d, it'll be at that positive number, or if it's negative d, it'll be at that negative number. It'll be a direct relationship, or directly, not the opposite sign. Okay, so we got x equals 2 and x equals -4. Let's see. All right, x equals 2 and x equals -4. So just pay attention to those tiny details and you're good to go. Whatever your variation is, find where the dotted line is. That's your one asymptote for function b. Find what makes this equal to 0, what x equals to make it equal to 0, or the opposite of what's happening to it. That's your other asymptote for function a. Last question. Which description is correct for the x-intercepts of function a and function b? Another vocabulary word. What does it mean to be an x-intercept? Well, scroll up. This has an x-intercept at 0. It crosses the x-axis. It intercepts with the x-axis. Well, this happens to be an x of 0 and a y of 0, but what's true for any value on the x-axis is y will be 0. Let me see if there's another. No, it's not a graph. The graph's up here. I don't think we have any more. I think they all are at. Yeah, they're all on. Okay, let me see. Actually, no, this one will work. Okay, so this intercept, hey. This dot does actually intercept the x-axis, and it intercepts the x-axis where y is 0, but x, boop, is +1. Okay, so if you had this variation, that's +1, and x is greater than or equal to it, that solid dot. So this x-intercept is +1, 0. So the key thing for x-intercepts is that the y value is 0, okay? G of x is the y value. It is the output value. So you're looking over here in this column for zeros. Okay, this one has a 0, -2, 0, +5. Perfect. Now they give you this function. Let's just copy it and put it in. Let's just take this and go copy. Come over here. Paste. It doesn't recognize that. So change out the symbols. Shift backslash, or if you want to down here, you can find the absolute value right there. Okay. All right, so now we have the intercepts. For here, we can just click on it where they intercept, -3, +3. Now we'll come back and see what options we have. A has 2 x-intercepts. Yes, it does, because there's 2 times where y is 0. So it'll intercept at -2, and it'll intercept at +5. B has 1. That's not true. Both functions have one negative and one positive. Well, -2, 0, +5, 0. That's true. -3, 0, +3, 0. That's true. And obviously, that's the correct answer, but you might have to check a different thing for your variation. Both functions have the same intercepts. That's not true. That's a -2 and a 5. That one's 3. They're both -3 and +3. Function B has 2 x-intercepts, and function A has 1 x-intercept. No, that's not true. They both have 2. And both have one negative and one positive. So whatever your variation is, that's how you identify the intercepts. Look over here where g of x is 0. Those are your intercepts. Go graph it and then just go click. Okay, and then think about which response fits your variation. All right, that was a lot of prior knowledge and a lot of different math skills that we've pulled in from this entire year to answer and compare function models. So it's okay if you're still kind of stuck or confused. Try to pause, repeat, and replicate the process I went through. And then let me know if you have questions. Feel free to email, call, text if you have any questions. All right, thanks for watching.